the second method of factorization, that is factorizing by using the method of regrouping. So before this we discussed in two videos. In the first video we discussed about the process of factorization and the different methods of factorization. And in the second video we saw that how to factorize an algebraic expression by using common factors method. Now this is the second method, that is by using regrouping, how we divide algebraic expression into its factors. Now see this problem. If you observe this algebraic expression, it is not possible to write common factors. See here we have a is common, but here a not there in common. So in 4 terms it is not possible to find a common term. So with the method of common factors, it is not possible to us to divide this algebraic expression into its factors. So now see what is problem here. In the two terms, in the first two terms we have a square and bc. No common term is there. So for that I am just rearranging this third term, I am sending to second place, and this second term I am sending to third place. For my convenience, I am changing the terms, order of the terms only I am changing. I am not changing any values. So now see here, after changing how it will be. The first term is a square plus third term is plus ab. So plus ab only I am taking. And the second term is plus bc. So I am sending plus bc. And the last term is plus ac as it is. So just terms I am changing. The third term I am writing in the second place, and second term I am writing in the third place. That's it. Now observe the first two terms. Here a square is nothing but a into 8. Here also one a is there. So from these two terms I am taking one a as common out. So what is left in the first term? One more a is there. Plus what is left in the second term? B is there. So first two terms I was written like this. Now observe the last two terms also. What is common in that? So in between plus is there, same plus only I am writing. In between these two, if you observe these two, C is common. So that C I am taking out. What is left? In the first term we have B, and in the second term we have A. So understood? Now see here, the first term is a into a plus b plus c into, we learn that commutative property. A plus b is equal to b plus a. Same like that, b plus a we can write as a plus b. Now see, a into a plus b is one term, c into a plus b is another term. In these two terms, a plus b we have common. So that common term I am taking out. A plus b I am taking out. So what we left in the first term? We have a, in between plus, and in the second term we have c. That c I am writing here. Now see here, a square plus bc plus ab plus ac. This algebraic expression we divided into its factors. What are those? A plus b is one factor, a plus c is another factor. So like this we can find the factors of an algebraic expression by just regrouping the terms, rearranging the terms. So hope you understood, and remember one more point, while we are regrouping and while we are taking common, keep one point in your mind, whatever we are getting here, this should be same in the two terms. Then only it is possible to take common out. Then only we can write it into a factor. So see one more problem. Here ax square plus by square plus bx square plus ay square. This I am regrouping as ax square. This third term I am writing plus bx square. X square like terms. That's why I am writing like this. Plus by square plus ay square. Y square like terms. So by observing this we know that in these two terms we have x square. So I am taking that x square as common out. So after that what we have? A plus b plus, in these two terms also I am taking y square as common out. So what we have? B plus a we have. And we discussed already, this a plus b is same as b plus a. So b plus a I am writing as a plus b. So from these two terms a plus b is common. So that a plus b I am taking out. So that we have x square in the first term and y square in the second term. So like this we can divide the given algebraic expression into its factors easily. Now see one more problem. Ax This minus ay I am writing in the second place because a like terms, and then plus bx minus by. So just I am changing the places of second and third terms. Now from the first two terms we can take a as common, so that we got x minus y. From the last two terms b we can take as common, so that we will get x minus y. So by observing these two terms we can take x minus y as common. So if we are taking x minus y to out, in the first term we have a, between these two we have plus, and in the second term we have b. So x minus y is one factor and a plus b is another factor for ax plus by minus ay minus by algebraic expression. So like this we can write an algebraic expression into its factors. Now see one more problem. See here, by observing this problem itself we can understand 7 common is there, z and z common is there. So like that, to take common terms as common, not rearrange the problem. So from that what I am taking, this 7xy I am writing first, and then minus 7. See, first term and third term places I am changing. Plus z minus xyz. So that is nothing but from these two terms 7 I am taking common out. So we have xy minus 1 plus from these two terms z I am taking common out. So 1 minus xy. Now see here, xy minus 1 and 1 minus xy both are not same. A plus b is equal to b plus a, but a minus b is not equal to b minus a. Commutative property is not satisfied under subtraction. So, but common theory ante manaki same terms undali. What we have to do? Simply take a minus common out from this. So already for x minus y we have minus. So that minus I am taking it out. So it becomes 7 into xy minus 1, and this minus I am taking, so minus into plus, it becomes minus z is nothing but xy minus 1. See, if you have any doubt you can multiply this minus z into xy minus xyz, minus into minus plus z into 1 z plus z. So from this only I am taking minus as common out. So now you observe this xy minus 1, xy minus 1 both are same. So I am taking xy minus 1 as common out. So in first term we have 7 minus, in the second term we have z. So like this we can write the factors for an algebraic expression z minus 7 plus 7xy minus xyz as xy minus 1 is one factor, 7 minus z is another factor. So like this we can write the factors for an algebraic expression in regrouping method.